Right, so we are here and we want to actually describe the set of points z in the complex plane that is satisfy the given equations, and we have a first, that is what we shall do, and that says the real part of the complex number 1 plus I z minus 1 is identically 0. So to actually solve this particular problem, what do? We let z be equal to x plus iy. When that happens, it means the real part of 1 plus I, like this, x plus iy minus 1 is 0. So what does this mean? This means that we have the real part. If you multiply everything, 1 plus x is x, 1 plus iy is iy, x plus that is ix minus y minus 1 equals 0. And so you have x minus y minus 1. Okay. And we put in parentheses like this, plus I into x plus y, and the real part equals 0, and we proceed furthermore to the other side of the screen. And what do we do here? We are still solving A, and so in solving A, what do we get? We take the real part of this complex number, and it is actually x minus y minus 1 equals 0. And that means y is equal to x minus 1. And we shall plot everything. Obviously, this one, okay, let's just first include the description here. So what kind of a set is this? So this one is actually a straight line. A straight line. Okay. So, and this straight line can be graphed like this in what we call the Argand diagram. We can sketch it. When x is 0, we can see that clearly y is minus 1. And obviously, we can see that this is the real part of z, and this is the imaginary z, like so. Okay, so we have exactly this, the imaginary z. And when y is 0, x is 1. And then we have exactly that. So in the equation of this line is the equation y equals x minus 1. And now seeing that this is the equation, we are able to realize, therefore, that this is the equation of the straight line. And therefore, this has been sketched in what we call the Argand diagram. Argand diagram. Okay, and therefore, this is the result in the straight line where to describe the set of points, and that is the straight line there. Okay, next we describe the next one, B on the next slide. Right, so this one we do the same, and we let Z be the complex number x plus iy, which means the imaginary of I into x plus iy, and we put the complex conjugate like this. We square it equals 2, and what is this? This is the imaginary part of I into x minus iy squared equals 2. Okay, the complex conjugate changes the sign of the imaginary part of the complex number. with the marginal part of, okay, if you distribute here is actually ix plus y, like this. All right. And then we take the marginal part of this complex number. What is the marginal part? The marginal part of the complex number is x. So we have this. So x, therefore, is plus or minus the square root of 2. Okay. And now what is this? How do we describe this? So this describes 2 points. It describes 2 points. Right, so these are, it means you have that x is the square root of 2, or x equals minus the square root of 2. Okay. And so now as this has been said, what is this? So the description is it describes 2 points, describes, okay, describes, or actually it's the set. Right, that's fine. Set of all points in the complex plane. Such that x is the square root of 2, or x is negative. Like this. Right, so what kinds of points are these? So we consider the Argand diagram. And in view of the Argand diagram, we have the following. Right, we have that this is imaginary z, and this is real z. So if you plot x equals the square root of 2, it is actually a vertical line like this. X equals the square root of 2. A vertical line that passes through the square root of 2, but also here we have the other one. X equals minus the square root of 2. Okay. Like this. Now, and this is the origin. So you have that these are the this is the graphical representation of the set of all points described by this. So this set, or this particular equation, describes 2 vertical lines through minus the square root of 2 or minus or plus the square root of 2. Okay, and we proceed now to consider the next question. All right. Similarly, when you get to this point, we let z be x plus iy. And when that happens, minus that, which is minus that. So we have this one, and then the IY here like this. Okay, you take the square root of this. X squared y minus 1. And here we have the square root like this. And we have y squared. You proceed to square both sides, and if you do, showing a little bit more steps here, so you have y minus 1, you square this. You square this like this. Twice into the square root of x minus 1. Squared that squared. Like this. And so if you square like this, so now you square this, and then you have this squared, which is 4 into squared plus y squared. Right, upon further multiplication of this, you can just write here. So this is exactly x squared plus y squared minus 2y plus 1. Okay, you distribute. This is x squared minus 2x plus 1 plus y squared, giving us x squared plus y squared minus twice y plus 1. 4x squared minus 8x plus 4 plus 4y squared. Okay. Okay, now, okay, which means you have 3x squared. 3x squared, and then obviously because that is 4x squared minus, that is 4x squared minus x squared, so that gives us 3x squared. And then what are we getting then from the rest of these here? You have minus 8x. Okay, now we have 4y squared minus y squared, which is 3y squared. 3y squared and then plus 2y. And then, okay, we've transposed everything. Okay, but now there is a 4 here. So if need be, you can just you transpose also the 1. That it gives the plus 3 equals 0. Okay, check carefully. You transpose this x squared to the y squared, the 2y, the 1. Okay, upon further division by 3, 3 plus y squared plus 2y over 3 plus 1 equals 0. Right, you complete the square without wasting time, so that's going to be x minus 4 out of 3 squared, y plus 1/3 like this squared, which is 8 out of 9. And this describes a circle. or can be described as a circle. It is a circle center. Right. It is a circle. Okay, it is a circle center what? Center 4/3 and minus 1/3. This circle is a radius. What is the radius of the circle? It is 2 the square root of 2 over r of 3. Okay, and therefore this one you can estimate, which is approximately 0.9428 units. Okay, so that is exactly the radius, or the radius is approximately 0.9428 units. And so that is what we get to be the actual radius of the circle. So it's not units. Okay. And so you think about this and sort of make sure that you understand these. Make sure that you understand these. All right. And now we just had to describe these particular sets of points, and we have just done that. Right, so this circle center, you can sketch this, is very easy. And now we also have the second diagram for these points. And you also have this one here is the straight line, and we've graphed it. Okay, so yeah, it's all good and well. And so thanks everybody. A very goodbye to you.